Hello, everyone, and welcome to our Tableau Server Certified Associate course. In this lesson, we'll be exploring the server processes that make up the core of Tableau Server, managed through the Tableau Services Manager, or TSM. Among the primary processes, the application server, also known as VizPortal, handles user authentication, permissions, and the web interface experience. The VisiQL server is responsible for executing queries and rendering visualizations. It turns user interactions into data results. The backgrounder handles scheduled tasks like data extract refreshes and subscriptions. The data server manages shared data sources, performs query caching, and handles data security rules like row-level security. You'll also find the repository, often referred to as PGGSQL, which is the internal PostgreSQL database used to store metadata, user actions, and configuration data. The cache server improves performance by caching frequently accessed data, and the gateway acts as the traffic director, routing incoming requests to the appropriate process. When you first install Tableau Server, a default set of processes is provisioned. On a single node installation, Tableau automatically configures a reasonable number of each process based on available resources. For example, you'll typically get one backgrounder, one VizQL server, one application server, and so on. However, Tableau Server supports multiple instance processes, meaning you can scale out certain components, like adding more VizQL or backgrounder instances, to improve performance under heavy load. So, how do these processes interact? Let's walk through a process-to-process workflow. When a user logs into Tableau Server through their browser, the gateway receives the request and passes it to the application server, which authenticates the user. If the user opens a dashboard, the VizQL server queries the necessary data, either from a live connection or through the data server, depending on the setup. If an extract needs refreshing, that task is scheduled and run by the backgrounder. Meanwhile, the repository keeps a record of these activities, and the cache server may provide faster load times by serving up previously used data. As your environment grows, you may deploy Tableau Server in a distributed or high availability configuration. In distributed setups, different nodes handle different process groups. For example, one node might focus on data processing, while another handles user sessions. High availability environments duplicate key components, like the repository and gateway, across multiple nodes to ensure continuity during failures. TSM allows you to manage these configurations easily, enabling failover and minimizing downtime. And finally, an important part of distributed and high availability architecture is the load balancer. A load balancer sits in front of your Tableau server cluster and evenly distributes incoming traffic across available gateways. This improves response time, ensures no single node is overwhelmed, and supports redundancy in the event that one node becomes unavailable. In conclusion, Tableau Server is built on a modular, scalable architecture managed by Tableau Services Manager. Thank you for joining us today, and see you soon.